Assalamualaikum warahmatullahi wabarakatuh. So today my group will explain about oscillation, building and bridge damper. In this video, we will explain about what is oscillation generally and what is oscillation in physics, and also how to avoid this to happen. Last we will discuss and conclude about oscillation and start to be taken to prevent the oscillation. Generally, oscillation can be defined as a process of repeating variation of any quantity or measure about its equilibrium value in time. Oscillation in physics occurs when a system or object goes back and forth repeatedly between 2 points or positions. So now we will discuss about oscillation in physics. So oscillation in physics has two, that is damped oscillation and also forced oscillation. The effect of the radiation by an oscillating system and the friction present in the system is that the amplitude of oscillation is gradually diminished with time. So the reduction in the amplitude or energy of an oscillator is called damping, and the oscillation is said to be damped. The mechanical energy of the system is transformed into the internal energy of the object and the retarding medium. For example, an object is attached to a spring and submerged into a liquid. Next is a simple pendulum oscillating in air. After being set into a motion, the pendulum will eventually stop oscillating due to the air. Okay, one common type of retarding force is force is directly proportional to the speed of the moving object and acts in the opposite direction of the velocity of the object with respect to the medium. This retarding force is often observed by an object moved through air, for instance. So let us move to another point, is that the force oscillation, another type of oscillation in physics. So what is force oscillation? Force oscillation occurs when oscillating system is driven by a periodic force that is external to the oscillating system. We have seen that mechanical energy of the oscillator is decreased with time as a result of retarding force. It is possible to compensate for this energy decrease by applying a periodic external force that does positive work on the system. Energy can be transferred into system by an applied force that acts in the direction of motion of the oscillator. Amplitude of the motion remains constant if the energy input per cycle of motion exactly equals the decrease in mechanical energy in each the results from retarding force.
So first type of damper is friction damper. So this kind of damper, it will dissipate energy by means of friction between the surface which are rubbing against each other. Okay, so for the second damper, it calls yielding damper. So this yielding damper, it will dissipate energy through its plastic deformation. Okay, so last but not least, the type of damper is tuned mass damper, or we call it as TMD. So this type of damper, it will vibrate the mass that move out of phase with the building motions. So it can sustain the structure of the building itself.
Now I'm going to explain one of the example of the application of damper in the building. One of the application of the damper in a building is Taipei 101, Taiwan. In July 2013, the building was hit by a typhoon, and in April 2019, the building was hit by an earthquake. However, the buildings are still standing until now. This is because the building applied a damper which is called tuned mass damper, or TMD, or vibration damper. TMD is a device consisting of mass, a spring, and a damper that is attached to a structure in order to reduce the dynamic response of the structure. The system consists of a cable that supports the mass, which allows system to behave like a pendulum. So when the seismic waves caused by an earthquake or wind hit the building, it will make the building sway. When the building sways, the damper will generate a force in opposite direction of the building. The damper will resonate out of phase with the building motion. Energy then is dissipated by the damper inertial force acting on the structure. The damper helps to reduce the amplitude of vibration over time, so the building will stop and back to its equilibrium form.
We can actually model very complex structures, such as these skyscrapers, as simple pendulums oscillating about an equilibrium. By using Taylor series expansions and some basic physics, we can prove that this model is indeed accurate.
There are several benefits of applying damper in a building. First, it helps to improve the response of a building under the seismic wave. Second, the building displacement will be smaller. And third, it will provide comfort for the occupant of the building as they experience less vibration. Fourth, it can lessen the material fatigue because when the building keep oscillates, the material of the structure will become fatigued and it will increase the risk of the building to collapse. And lastly, it will decrease building damaging effect. This graph shows the comparison of displacement between a building with a damper and a building without a damper. It can be seen that a building without a damper will experience more displacement. In theory, the movements of a building without a damper will become increasingly bigger and this may lead to the building to collapse.
To conclude, every building needs dampers to sustain their structure. This actually can avoid the building or any skyscrapers fall during natural disaster, for instance, earthquake or typhoons. So when vibration of buildings may assume to be elastic and linear, and someone may think to reduce the vibration, we can apply some appropriate mass. But actually, we can coupling an oscillator with the main structure. Actually, this oscillator can absorb energy at certain frequencies, and this oscillator also often coupled by a spring damper system in order to sink energy from the system. So next, we need to know why it is crucial to have a damper in a building. So actually, damper systems are designed and manufactured to protect structural integrities, to control structural damages, and to prevent injuries to the residents by absorbing seismic energy. So we need to think where dampers are placed. So dampers are strategically placed in the building structure to control the floor vibrations and also the building displacement. And last but not least, this damper also cater for occupancy comfort. So all the energy generated by the flow of vibration and building displacement is absorbed by the dampers and dissipated through the heat energy. So these are the suggestions to avoid oscillation occur in the building. First, about the structural strength consideration. It is to ensure the strength is enough to resist peak dynamic forces acting on it. So for the second suggestion is about the inexpensive approach. So what can we do is we can increase the floor loading within the building. So the weight place can minimize the movement and dissipate vibration. So for instance, foot traffic experience on the building itself. So by this kind of approach, we can minimize our budget. So next suggestion is precipitable compatible vibration. So this suggestion should be carefully assessed by the designer itself. It is especially for the building that have unusual geometry and complicated structure. We need to bear in mind that the impact of vibration becomes more difficult to accurately predict and effectively minimize. So before we want to build a building, we need to consider this suggestion. So last but not least, designers should consider about the level of acceptable vibration, because during this concept, building designers should consider this matter as it can be very difficult and costly to modify an existing floor to reduce its susceptibility to vibration.
That's all from us. Thank you. Bye bye.